I'm going to make a periscope, a cuboid periscope. I have managed to find a thick cardboard, and you can see that there is a depression in the middle. It's not in the middle, and there are two adjacent sides which are not equal. So first I will make both adjacent sides equal. I took a measurement of the smaller side and I will cut out some portion out of the longer side so that the both adjacent sides can be equal. I am using a cutter. You can use a combination of cutter, scissor, knife, whatever that comes handy, but not don't cut yourself. Be careful while cutting. I have explored two different models of periscopes earlier which have different capabilities. You can visit the website or see the earlier video to see how does that vary with the one that I am currently making. So I have cut out the portion, and now we can see that the two adjacent sides are equal. I am going to fold the two adjacent sides from the middle. Take a measurement, mark the middle. There is one periscope that I have explored earlier can be rotated manually to see sideways and in the back. So I am pressing pressing the straight line with my nail to make a depression there. That will help me in folding along the line. Without that, it will be harder to fold along the straight line as the cardboard is very thick and you may not be able to fold it along the line. As you can see that the depression is clearly visible. It can be folded very easily. Now I'm going to do the same to the second half. Take the measurement, mark the middle, make a straight line through it, press along the straight line with the nails. There is also one periscope that I have explored earlier which can be extended, meaning that the height can be adjusted. We won't be able to adjust the height with this periscope, and also we will not be able to rotate. So I have find another solution to see sideways and in the back with this cuboid periscope. Now, the four depressions can be easily noticed, all having equal lengths. Here we have this shape of a cuboid with two equal sides and one unequal side, and that is the longer one. Now I'm going to stick the edges with a glue stick. You can also use the tape. But tape is easier to come out, so I have used the glue stick. It will be able to hold it better. Apply the glue and leave it to dry for some time and then move along. A periscope is not just an optical device that you see in optics books. It can it can be used in our home. It finds its uses in a lot of places. Sometimes we want to see the shelves that are not easily accessible, and we have to move chair to see those shelves because of our height. We can use the periscope to see those shelves that is beyond our reach due to our height. We don't have to move the chair. It is handy. It can be easily moved around in the home. It can be made with very few components, easily accessible in the market. A periscope is a gateway to a world of ray optics. We will be able to see how the image formation happens through the light rays. That's why we have these straight geometries. A long cuboid with straight line along which the light ray will travel along. So our cuboid is ready, a cuboid periscope in making. Here is this mirror that I am going to insert in the cuboid. I am making a right angle triangle with two equal sides. The purpose here is to orient the mirror at 45 degree with the long edge. So I will make a right angle triangle with two equal sides and make a slit through the hypotenuse. The mirror can be inserted through the hypotenuse. Right angle triangle is one way to make a line at 45 degree to the long edge. You can also use other ways. The purpose here is to make that line at 45 degree to the long edge. Again I am using the cutter. I took a thin mirror. So select a mirror that is thin, not a thicker one, as it will be harder to make a slit thicker. I am using the scissor to make the slit a little thicker so that mirror can go through it. As you can see that the line has to be made a little longer. Now you can see that the mirror can easily be inserted. It fits right through it. I am doing the same at the other side. Again a slit through the hypotenuse, but you have to make this two hypotenuse parallel. Make a line that is 45 degree to the long edge. And make the hypotenuse parallel. This will be the orientation with which we are going to see in the front. Here I have made the slit, two slits parallel. Now I am going to make a window through which the light ray will be able to come. This will be like a flap that you can close it when it is not in use. So whenever you are uh, seeing the sideway or the back, you can close the other two flaps. So you will be needing three flaps, one to see the front, one to see to the sideway, and the third one to see in the back, and three slits. One slit and one flap at one side of the long edge to see through, and three slits and three flaps at the other end to see the front, sideway, and the back. It will be a very useful practice in the ray optics. Here I am inserting the mirror. That end I am going to see through, and this is the other end. You can see that the mirrors are parallel. This is the orientation with which you are going to see in the front. The flap, the two flaps open. Two mirrors parallel facing each other. The flaps in the opposite. Here is the wall clock that I am going to see through the periscope to see that if it is working or not. Here we can see that the wall clock is visible clearly, so we are sure that the periscope is working and it is ready to go. Here are three flaps that I am going to show you, three flaps and three slits. This is the orientation with which you are going to see in the front. Open the flap and it is ready to work. Make a diagonal slit, and now with the flap open we can look in the back.